So he was trying to get the rhythmic thing working by changing the delay knob. And it's like, and he was sitting there tweaking, and they showed him on the show tweaking the delay knob to get the perfect delay to match the song. And I guess since he hadn't played guitar for a number of years, he didn't know that they had tempo pedals now. And it could have been much, much simpler. But that's a good example. The edge is, you know, what Kirk Hammett is for the wah pedal, the edge is for the delay. And his delays are not only are they deep and thorough, they're only certain devices, you know, the edge delay is a certain chord box, I believe. And it allows modulating delay. So we'll talk about what that is. But you know, it's very thick sound. Other great examples, Run Like Hell by Pink Floyd. You know, you hear the. And that's got kind of a little bit of feedback, a little bit of echo, which we'll talk about. And then this is an example of using a delay to make it sound like you're playing faster than you are. This is called Flight of the Wounded Bumblebee by the Sweden. You can hear it. So the delay there, every other note you're hearing is actually a delay. So it's not playing as fast as it actually is. But it's not apparent at first. Okay, other delays. There are variations on the theme. You can get what's called a multi-tap delay. And what that has is it has multiple delay lines in series, or you can do it in parallel. And then you can combine them. And I wish I had brought in my Yamaha Magic Stomp, because the Yamaha Magic Stomp will actually allow you to do, I believe, an 8-tap serial or 8-tap parallel delay with some crazy delay time. So you can have 8 parallel delay lines that you set up, and it allows you to configure them all on the screen because it's USB controlled. So it's great. I have the software. Unfortunately, I forgot the pedal today. And actually, that is a model from an older Yamaha pedal called the UB Stomp, which was the UB Stomp was the delay modeler, and it could do all kinds of things. Another fun one is ping pong stereo delay. And what that is it has a delay on one side, and then you create a stereo path that is that delay with more delay, and then it feeds back and forth. So you get this ping pong effect where the delay bounces back and forth by itself as the delays indicate that. Now in these paths, I showed a feedback path, right? So the output often can be varied back to the input, and typically there's a gain control on that. So like here, where the feedback path loops, this feedback has a gain device on it. And I'll describe that a little more when I get to echo. Now another thing to note here, this comes in handy later, is if you look at your frequency response, consider a delay line as an FIR filter, right? You've got a 1 on your first tap, you know, which is your most recent signal. And then you've got a bunch of zeros. And then you've got some delay element with some gain, right? So if you look at that, and you can view it as an FIR filter, you've got the most recent sample and some long delayed sample. And if you had multi-tap, of course, you could have other taps with values. And we'll say, well, okay, well, what happens if I look at the resulting spectra of that? And so you can just plug it into FreeZ and see. And what you find is that you have, it's not flat like you think of. I mean, you don't think of a delay as altering frequency. You actually have notches in the frequency spectrum. And the longer the delay, the more notches. And if you think about it, it makes sense. If you have, say, 100 hertz tone, right? That is a period of 10 milliseconds, right? So if the period of 100 hertz tone is 10 milliseconds, Well, what happens if you set your delay for 5 milliseconds? You create a signal that's 180 degrees out of phase with that 100 hertz thumb, just by running it through a delay. So you can see kind of intuitively how this cancellation comes about. You're delaying certain frequencies by x times 180 or some variant. And that's where these notches come from. The certain frequencies cancel. And this is very important for chorus and flange, which we'll look at next. The other thing that I'd like to call out is, I mentioned before, we had delay and then the delay mix, and then we have feedback pad. And most delay units have a feedback pad, where you can set the delay time, you can set the delay level, and then if you turn your feedback to 0, you play it once, and you get the input copy, you get the delayed version, and then that's it. But then if you do the feedback, well then the delay gets filtered back into the delay, so you play it once, you get an output copy a little bit later, slightly attenuated, then you get another copy slightly attenuated a little later, and again, fade back. I typically call this echo. I mean, most people don't make the distinction between delay and echo, but I like to call this echo because it gives that echo, you know, it keeps going. This feedback gain is typically less than or equal to 1. You know, especially with digital delays, you set it so that it can go up to 1, but generally it'll fade out or continue to keep going. With a lot of analog pedals, you can actually sometimes get beyond unity gain, and you get what's called a self-oscillating delay. And the Chord PME delay I brought in does that, and I'll demonstrate that. The other thing you can do is you can put a filter in there, in that feedback loop. Or if you really want to go crazy, you can actually put a whole extra effect in there. Some of the build your own clone ones and other do-it-yourself boxes have a way of modifying the feedback path. You can stick a send and return, so you can put an effect in there. You can get some really great sound by doing that. But say you just go with a simple filter. Well, if you want to do that, what you might be able to do is take a digital chip. Like I think I mentioned the Princeton Technologies chips. They are a digital delay on a chip. They have the A to D, the memory, the D to A, everything's there for you. And they allow you to do the feedback analog so that you can simulate a bucket brigade delay. And I have another delay I brought in that is exactly that. It's the Ibanez DE7. It's a digital delay, but it has 2 modes. Delay, which sounds very digital and very clean, and echo, which uses feedback filter and probably some other variations to sound like an analog echo. And it does oscillation. And it's actually, if you can't get, bucket brigade delays, what most people call analog, are more expensive. The chips aren't being made as much now, and the newer ones supposedly aren't as good, etc. But this pedal is a great simulation of it. So we'll play with that and we can compare it to the real bucket brigade delay chord. Okay, so that's echo, or what I like to call echo. Now, the original implementation of this was tape echo. And tape echo was kind of an ingenious, kludgy way of solving this. You know, we're talking about in the 60s, you wanted to create a delay. Well, the best memory you had was magnetic tape. So what they would do with tape echo is they take a big loop of tape, they run it through some pinch rollers, right? Because that's how a cassette tape works. It pinches the tape and shoves it through. You record on it, you have some delay, and then you play it back, and then if you want and then you erase it. So this is your delay line, and then if you want feedback, you do feedback through an analog path. And then if you want to vary the delay time, you vary the speed at which the tape moves. Okay? A great example is Tommy Bolin did a lot of work. One of the guys, my favorite operators of a tape delay unit. Although a lot of people have done good stuff with it. This is a good example of tape delay. So it's just played once.